Assalamualaikum and good day everyone. Today I'll present about bismuth, a unique heavy metal known for its low toxicity despite its heavy metal status. First, let's look at its basic chemistry. Bismuth commonly exists in oxidation states +5 and +3, with +3 being the most stable. This is due to the inert pair effect, where the ns2 electrons behave like a reluctant pair that prefers not to participate in bonding, making the +3 state more stable. Now, unlike main heavy metals, bismuth shows very low toxicity, and this can be understood by looking at how it behaves inside the body. To make it easier, imagine the human body as a high security building. First, bismuth has very low absorption because it is poorly soluble, less than 1% enters the bloodstream, meaning most of it cannot even pass the main entrance of the building and is quickly removed. When a small amount does enter, it does not move freely. Instead, it binds to transport proteins like transferrin and travels through the bloodstream. This process, known as molecular hitchhiking, is like bismuth hopping onto a minibus to move around inside the big building. Next, when bismuth reaches the cells, it can interact with important biological systems. Inside the cell, enzymes normally rely on metals like zinc and nickel to function properly. These metals act like perfectly shaped keys that fit into a specific locks. However, bismuth can sometimes replace these metals. It looks similar enough to enter the lock, but it is not the correct key, so the enzyme cannot function properly. Because of these, biological processes are disrupted, especially in bacterial cells. This explains why bismuth shows selective toxicity, which mainly affects the bacteria rather than human cells. So why are human cells less affected? This is because human cells have an efficient detoxification system, mainly involving glutathione. In our building analogy, glutathione acts like a security and cleaning team. It quickly recognizes bismuth, binds to it and forms a complex. Then, special transporters known as MRP transporters escort the bismuth out of the building. As a result, bismuth is rapidly eliminated through urine and feces instead of accumulating inside the body. Another important concept is whether bismuth pretends to be a nutrient. From what we have seen, bismuth does not fully imitate nutrients structurally. Instead, it shows partial or indirect mimicry, specifically in functional mimicry. This means it behaves similarly in function, like stepping into zinc's role, but it is not an exact copy. So in our analogy, bismuth like fake key that can answer the lock but cannot do the job properly. Finally, in Malaysia, bismuth is widely used in therapeutics, medications, and cosmetics, and it is strictly controlled by the National Pharmaceutical Regulatory Agency (NPRA) to ensure safety. So overall, bismuth can be understood as a control imposter in high security building. It may enter and interfere slightly, but it is quickly identified and handled and also removed. Thank you.